Here we're looking at something called a cyclic quadrilateral. It's a quadrilateral with a particular condition. So how do you put it across this? Say we have 4 points on the circle. It's something like this. Okay, so C and D. So if we join this, we'll get a quadrilateral. So if this is X and this is Y, if this is A and this is B, right? So the cyclic quadrilateral has a particular property that the opposite angles will add up to 180 degree. Okay, so cyclic quadrilateral is a quadrilateral whose vertex lie on the circumference of a circle, and the opposite angles will add up to 180 degree. Okay, so that's a cyclic quadrilateral. Here we have been given that ABCD is a cyclic quadrilateral. So first of all, we need to know what is a cyclic quadrilateral. I hope you guys understood that. Not angle, vertex of the quadrilateral lie on a circumference of a circle, of a single circle. So if ABCD is cyclic quadrilateral, the theorem tells that. Now we are talking about the theorem. Please understand. I made you guys understand about cyclic quadrilateral, and now we are looking at the theorem. Now the theorem tells that the opposite angles will add up to 180 degree. Okay, so this two will add up to 180 degree, right? So let's look at this particular question. So clearly we can see that this is a cyclic quadrilateral. How is that? I'm telling what confirmation is there to tell that it's a cyclic quadrilateral. As you can see, this vertex are on the circumference of the circle, of the same circle. So this is a cyclic quadrilateral. With that in mind, can I find these two angles? Yes. 60 plus what will give me 180? 120 degree. 80 plus what will give me 180? 100 degree. And with this, we can tell that this is a cyclic quadrilateral. Okay, I mean with also that actually, but anyways, we confirm that this is cyclic quadrilateral and we'll be able to find the opposite angles. Now the converse tells that if we have 4 points, okay, so say we have 4 points A, B, C, D, or M, N, O, P, something like this. Say we have 4 points and let's call them as M, N, O, P. This is X, this is Y, that's A and that's B. So here if I tell if X plus Y is equal to 180 degree, or remember this is or, if I tell A plus B is equal to 180 degree, if the opposite angles add up to 180 degree, then I can confirm that then MNOP is a cyclic quadrilateral. Okay, so here it's the other way around. If we happen to have a quadrilateral whose opposite side add up to 180 degree, then it's a cyclic quadrilateral. That is, I can draw a circle around this 4 points, touching the 4 corners. Okay, yes, you can imagine a circle going past all of this 4 points. Now to complete, I have 2 questions for you guys. So you guys have to tell, is this a cyclic quadrilateral, or is this a cyclic quadrilateral, or are both cyclic quadrilaterals? The answer here is no, and the answer here is yes. So why is it no over here, yes over here? It's the same diagram and the same values. Because we cannot confirm if opposite angles add to 180 degree. See, this is 70, but we don't know how much is this. This is 110, but we don't know how much is this, right? But here we can confirm that opposite angles add to 180 degree. So this is a cyclic quadrilateral. Understood? We don't know, we can't tell about angle A and C. There's no way of telling about angle A and C, but surely we can tell that this is a cyclic quadrilateral. So we need not know the information of all the angles. Just one pair of angle, that two opposite, and they are adding up to 180. We can tell for sure that it's cyclic. If these two don't add up to 180, then it's not cyclic. Okay. Here we can't, actually the answer is yes or no. It might be or it might not be. But as of now, with the given information, we can't tell that yes, this is a cyclic quadrilateral. Okay. So this is your answer, and you guys need to write this up.